Hello everyone, how are you all doing? My name's Aaron from MLH, and this is the basics of blockchain with Horizen. I've not done these workshops for quite a while. It's awesome to be back, and I can't wait to show you everything we've got in store today. So first, I guess I should call out registering and checking in for the event. So I'm going to go ahead and share my screen while I go ahead and do that. It's really simple. All you have to do, one moment, let me be special for a half second, and get a second screen share working. I do believe I can do that. I need to mute that tab though. So if I go ahead and share my screen, I want to share the basics of blockchain with Horizen tab. You can now all see that. All you have to do is head over to hackpack/LHD-share-Horizen. I'll go ahead and chuck that link in chat for y'all right now. And then once you've logged in with your MyMLH account, you'll see this page with your lovely face in the top right corner. Click register and check in, and it's gonna wait a second. And then you're checked in. It is really that simple. So head over to hackpack/LHD-share-Horizen, log in with your MyMLH account, and then click register and check in, and you'll have done it, which is super awesome. You land on a Zoom call and the fact that the live stream is going on here. That is an interesting problem. Let me go ahead and fix that real quick. Believe I can update that link. Let me just check what I have to do that. I need to be logged into a different account. But thank you for calling that one out. That's super useful. We were meant to be. We would have been on Zoom if this was not during local hack day share, but because it's local hack day share, we are gonna be on Twitch. Let me go ahead and update that, and then go to virtual event and mark it as approved. So now if you go back to that page and you click join online event, it will take you to Twitch. Perfect. That's now been fixed. Thank you so much, all of you who called that out. We are in fact on Twitch today. So go ahead and make sure you've checked it at hackpack/LHD-share-Horizen. Page looks a little something like this. And we'll go ahead and get started from there. I'll keep the banner up on screen for all you for the next little bit. Maybe he's asking where the leaderboard link is. I am 99% sure hackpack/leaderboard works. It does. There you go. There's a leaderboard link. Awesome. All right. So let's go ahead and I guess jump back into the basic blockchain with Horizen. Let me know if my music is too loud and I'll lower that for y'all, but should be fairly straightforward. Number 5 on leaderboard is amazing. Well done. So question: we were sent a link to a Zoom call. To be on that Zoom call, or do we have to be here? Nope, we are here on Twitch. We do not need to be on that Zoom call. If you have any friends who attend that Zoom call, make sure to tell them to head here to register. I'm going to edit this banner so it's scrolling. It makes a little bit less obtrusive. Awesome. Any other questions of comp already? Yep, that should be fixed now. Don't worry. It should take you straight to Twitch. You're in the right place. Don't worry. All right, so basics of blockchain with Horizen. First, to call out MLH, we are the global hacker community. Our mission is to empower hackers all around the world. This week, we're empowering hackers at Local Hack Day Share, our third iteration of Local Hack Day this season, which is super awesome and tons of fun. Make sure to check out Local Hack Day at lhd.mlh.io. And if you aren't already checked it and then registered for Local Hack Day, I'm going to show you how to do that right now. All you have to do is go to lhd.mlh.io, and I've somehow managed to screw that one up, and you'll get taken to this awesome page. Click sign up, and it's going to take you to Local Hack Day Share. I'm already registered and checked in, but it's the same exact idea. And then once you've done that, go ahead and go do the week-long check-in, which is actually the same link. Sorry, the day 1 check-in, and then click again, register and check in on that page. Have I not done that right? I haven't done that right at all. I do apologize. We want to show this page. Again, another HQ page, and then scroll down. Also click day 1 check in, and you'll see this page. Again, you can register and check in just there. All right, let's jump back into the workshop. And we'll talk about Horizen. That is a great question. What is Horizen? We're going to talk about Horizen in just a moment's time. So first up, what are we going to be doing today? So I'm going to talk to you a bit about MLH, then blockchain, then Horizen. We're going to create Sphere wallet accounts, and hopefully, fingers crossed, I'll be able to send you Zen. Currently, a bit of a shortage of that on our end, which is but we are actively working behind the scenes to make sure we can get you all the Zen you need. All right, so let's jump into an introduction to blockchain. We're going to go over an introduction to blockchain technology in Horizen, how to create a Sphere wallet and send and receive transactions, and how to deploy and run an application that uses the Horizen blockchain. So go ahead and throw in chat. When you hear the word blockchain, what do you think about? For me, I think the obvious one is things like Bitcoin and Ethereum, which are two pretty big uses of blockchain in the news right now. I am a PC gamer, and the shortage of GPUs bothers me immensely because of cryptocurrency. But yeah, I'm seeing crypto, Bitcoin, chains of transactions, secure transactions. These are all awesome. The lack of a 3090, that is an actual mood. But secure transactions, Bitcoin, cryptocurrency, buzzwords, that's totally valid. Decentralized, that's a word I really like to see. Also NFTs related to blockchain, right? Yes, I do believe so. That was became quite relevant in the news recently, because I think Jack, Twitter's CEO, said that sold the NFT for the first tweet that was ever on Twitter. Connections in a stack/block. Yep, that's kind of correct. We're going to go over all that in just a moment. So, Web3, kind of. I'm not amazingly familiar, but I do believe there's some relevance there. I know the Web3 Foundation does a whole lot of blockchain Perfect. All right, we do have Sphere coming in. That is Zen coming in. That is fantastic. D-apps, yes. Again, we're gonna be building a D-app today, so that's awesome. Decentralized parking, Bitcoin, yep, all fantastic examples. Something like a firewall, not quite. We'll be going into that in just a bit. If you want to see if y'all want to see a blockchain transaction in real time, that is me getting access to some Zen to send all of you later on in this workshop. Privacy, absolutely. And yep, there will be a quiz at the end, and I will show you that, but we have to go through the workshop before we can get to the quiz. So what is blockchain? Blockchain is a data structure. Common examples of blockchains, common examples of data structures are lists or tables. If you've heard of a linked list, blockchains are basically a decentralized and massive linked list in that respect, which is super, super cool. So the blockchain is a chain of blocks. Linked lists are awesome. They are super, super versatile, and they are the backbone of a lot of other data types. But the blockchain is a chain of blocks. Each block is a collection of data similar to a folder on your desktop, and each block knows what block came before it, and thus forming a chain. You can think, if we're going off this linked list metaphor or analogy, blockchain is like a singly linked list. Yep. So, yep, that was an error. We have since fixed that. That link now takes you to Twitch. I do apologize for any issues there. Just make sure, if you are able to tell anyone else that's there to come to Twitch, that'd be great. And make sure you've checked in at hackpack/LHD share Horizen. All right. Yep. And data structures stores data in a structured format. So some examples of data structures would be linked lists, which are blowing up in chat, arrays, hash maps, binary trees, B trees, etc., etc. I mean, yes, this is actually a very fair statement. It's very, very common for first-year computer scientists to have to create linked lists in C as a part of their coursework. But I think it's a great learning experience in that sense. Let's talk about centralized systems. Decentralized came up a bunch in chat, so let's talk about decentralized systems. Most data is stored in databases. For example, user data on Facebook, or your order history on Amazon, or your videos on YouTube, those are all stored in centralized databases. Databases are highly efficient but centralized, and a central entity decides who can add data to a database, who can modify it, and who can delete data from it. The TLDR there is everything has to go via that central entity, and if you want to transfer information to someone else, that information has to go from me to that entity. That could be Google, YouTube, Facebook, Twitch, and then to the recipient. I got some questions in chat. Can a blockchain be doubly linked or circular linked list? So circular would sort of defeat the way blockchain works. So I'm going to say no. In theory, you could create a doubly linked blockchain. In practice, I think a lot of systems will treat one as such, but I will honestly say you basically have to, one of the big benefits of blockchain, right, is you can't alter the history of it. In order to create a doubly linked blockchain, you would have to edit each of the previous records to point to it. It's almost like a reversed singly linked list in some ways. A singly list structure are common for all kinds of blockchains. Are they different in Bitcoin and Ethereum? I am no expert in Bitcoin and Ethereum, but I'm going to say a singly linked structure makes the most sense to me in terms of trying to explain how they work. Why the badly gone green screen? You can blame NVIDIA broadcast, and I normally have a different image back there. Don't worry about it. It's totally chill. All right, so I mentioned YouTube or Google. So let's think of YouTube, which has a database to store all your videos, all my videos, all of PewDiePie's videos, etc. Right? What happens when YouTube decides to delete your video because it thinks it's inappropriate? What will happen if YouTube puts it down? Actually, a great example. There was a fun thing with YouTube recently where a bunch of accounts that probably shouldn't have been were getting suspended. I was one of those accounts, and I had no access to YouTube for 2 days, which, as someone who uses it a lot, is quite disappointing. So in that sense, right, that's a bit of a wake-up call that centralized systems, they have a lot more control over how you interact with them, which sometimes is good, but sometimes is really, really frustrating or really bad. But if YouTube decides to delete your account, delete your videos, or if they shut down, you lose access to your videos, those that you created, you loved, etc., etc. Why did I get suspended? I got told I broke their terms of service, and then 2 days later they said, nope, you didn't actually break our terms of service. So, you know, always fun. So blockchain is presented as a solution. Decentralization, as the name suggests, removes this central organization and introduces a more collective system. The masses control the data, right, as opposed to one individual. And blockchain is a technology that allows us to do this. Blockchain was invented in 2008 to help solve the problems that can arise from having a single centralized source of knowledge. It's sought to create a decentralized platform, one where there is no single source of truth, i.e. there is, and all the knowledge was shared collectively, right? Every single block, kind of, not actually the case, but every single node in a blockchain, technically speaking, knows the entire blockchain. Now, in practice, that's not actually how it works, but that's the principle of it in that respect. So again, let's go back to our YouTube example. What if everyone has to create a copy of all the videos created? All new videos are verified by everyone's YouTube video copy. Only the rightful owners of a video are able to edit or delete it, and videos are sent directly to one another, peer-to-peer, instead of through a central application like YouTube. This would not have been possible without the internet and computing power needed to rapidly compare our sources of knowledge. Faster internet like we have today, modern broadband, is really makes this possible. This would have been a horrific task in the 90s when dial-up was pretty much the only solution. There's more questions coming up in chat. If anyone wants to know more about the structure of blockchains, you might want to look up Merkle trees. Fantastic. Go ahead and take those up. He linked to an Ethereum blog post. I am not going to say that's great or not. But it is there. Why don't we stream on YouTube? We should be live on YouTube. It says we're live on YouTube, but there's 0 viewers. I don't know. We do stream to YouTube. Something might have gone wrong with our configuration there. I don't know. So in sort of short, whatever there is on a blockchain network stays on that network. Yeah, that's fairly accurate. It's like servers, nodes. Yeah, nodes can be servers, right? When you see like mining farms and stuff, right, for blockchain or Ethereum, each of those nodes is each of those computers is technically a node, and calling something a server is kind of an arbitrary term, right? Any computer can be a server. It depends on what it's doing more than anything else. Isn't peer-to-peer transactions more susceptible to cyber threats? Yep, that's not wrong, right? Peer-to-peer, there are potential vulnerabilities in the peer-to-peer configuration, right? You're exposing your IP address and stuff like that. But like with everything in technology, there's pros and cons to every different approach. I'm not going to go break down the specifics of that. But yeah, in peer-to-peer, every node acts as a client and server. Yep, that can be correct. It depends, right? If we're talking about the BitTorrent protocol, right, when someone is leeching, they're not really being a server at that point. Can you explain the term all new videos are verified YouTube copy? So the TLDR is, right, if I am serving, right, if I am serving data to if I'm serving something as a member of a blockchain, right, in a peer-to-peer network, I have to prove that the file I'm sending you is actually the right file, right? So you're going to compare it against a hash that's verified. Everyone knows to be true, right? Which could be YouTube's one, right? That's an example. Don't have to worry about this. That was a link to. That's an example of a cryptocurrency transaction on Horizen's blockchain. We'll look more at that in a bit. So let's go over a history of blockchain. The key to blockchain is cryptography. Each new block in the ledger is linked to a previous one with a highly secure cryptographic hash, making them incredibly difficult to modify. You can't recreate the file from the hash. That's why it's a one-way algorithm. The history of cryptocurrencies and how they work is in another workshop itself, so I'm not going to go into too much detail here. And the secret of peer-to-peer verification is the cryptographic hash. They are extremely difficult to break with current levels of computing power. The massive asterisk there is quantum computing theoretically can, but quantum computers are not even remotely ubiquitous yet, so not really much something you have to worry about. If folks are interested in Bitcoin, direct them to check out Bitcoin's white paper. That's bitcoin.org/Bitcoin PDF. There's a link to that for y'all. If you think there was a link to an Ethereum equivalent earlier, those are totally options. But blockchain is a chain of securely connected blocks of data. Blockchain technology took off in 2008 when an unknown person who used the pseudonym Satoshi Nakamoto used blockchain technology to create the cryptocurrency Bitcoin. And yep, as I reiterate, why the name blockchain? Because each block in that list of that data type or data structure, right, is chained from block to block, right? If you were to actually take a physical chain, right, and each link would represent a block in its own right. As a quick remember, a cryptographic hash function is an algorithm creating a one-way unique fingerprint hash of a file. So that link that I put in chat earlier, that very long string, that is technically a hash from Horizen's network. So what can we use blockchain for? Digital currency is one major use of blockchain, but it's definitely not the only one. The TLDR here is anywhere that data is used more than one part is used by more than one party, and where it needs to be verified and stored securely, it's a potential use case for blockchain. So blockchain is great for governance. You can bring full transparency to elections, making results fully transparent and publicly accessible, right? If voting machines were connected to a blockchain, you could very quickly see what it was, and then maybe get a receipt of your transaction on the network for an election, right? And you could very clearly see what was going on. We're gonna ignore the other potential. We're going to ignore the potential of other security threats there, but that is a one notable example. Healthcare, private health records may be encrypted and securely transferred. I admit I couldn't explain that for you, but it is an option. And then blockchain can provide automated handling of royalty payments for music, which is actually quite a cool concept in its own right. So what can we use blockchain for? One of the biggest uses of blockchain is to enable the transfer of digital currency. This is called cryptocurrency. Cryptocurrencies use cryptography to provide secure online transactions. The first cryptocurrency was Bitcoin. However, there are over 2,000 cryptocurrencies currently in the market. Zen is the native currency, Zen is the native cryptocurrency of the Horizen network, which is a network we're going to be building a DApp on today. And then where data is used by more than one party, like we said, it can be verified and stored securely as a potential use case for blockchain. So why cryptocurrency? Are there benefits to using cryptocurrencies rather than normal currencies like the dollar? Those are called fiat currencies. So, since they leverage blockchain to transfer cryptocurrency is decentralized, secure, theoretically always available, right? The chance of it going down, it basically to break the internet, right? And I'm pretty sure your access to ATMs would break too if the internet died. So, I'm not sure. Global transferring cryptocurrency is much cheaper for international transfers than regular currencies. That is generally true if you're comparing to things like SEPA or SWIFT, right? And it can be anonymous. Zen provides special addresses called shielded addresses, transactions between which are completely private and anonymous. What is digital currency? Can I explain it in simpler terms and go a bit slower? I will do my best. So I guess the reason why anything has value, right? Could be bread, a brick, a block, a bar of gold, your television, the US dollar, the euro, right? Why any of those have value is because something says that has value. In the case of fiat currencies, the government is telling you that has value to do certain things, right? That could be if we're going to go into economics, right, that could be bonds to the government and stuff like that. The reason why oil or gold and stuff like that has value is because the market dictates its value, right? In the case of fiat currencies, most currencies are backed by gold to some extent, right? The U.S. has a very, very, very large stockpile of gold in the Federal Reserve and stuff like that. So the same idea kind of holds with cryptocurrency, right? When the masses say that one Bitcoin is worth $60,000 or whatever it's currently at, right? Right, you can then if you can prove that you have that bit of a piece of that currency, right, and you can spend it and share it via the network, right, you can then the people are acknowledging, yep, you have $60,000 worth of Bitcoin, which in terms of what that looks like from a computer science perspective, we've been talking about blockchain for the last half an hour, and effectively on that chain, we'll say, hey, on that chain, the rest of the network will acknowledge, yep, you have that currency, you can spend that currency. And we'll go into how that works a bit more later. A bunch of great answers are also being thrown in chat about that. I think someone was saying to look at the Ethereum yellow paper. I am not amazingly familiar with it, but feel free to go with it. Is a Pi worth mining? I don't think a Raspberry Pi is going to mine on most networks particularly effectively. I'm not going to go into mining today. That's a totally different topic. But yeah. Let's talk about Horizen. Horizen is an inclusive ecosystem with the following components. Zen, the cryptocurrency with full end-to-end encryption to protect internode communication. Infrastructure, a robust network of 916 nodes that form the Horizen main blockchain, or their main chain. You can also refer to that as a main net. Sidechain technology, a solution that allows scalability of blockchains by allowing application-specific blockchains that can interoperate with one another. TLDR, what that means, right, is if it can be very, very slow to build an app that has to be published across every single node of the main chain. So we can make these side chains to sort of specialize in different applications that have to sort of validate with the main chain in a different way. Apps, products, and services built on Horizen's infrastructure and technology such as ZenChat and Sphere. ZenChat's a messaging application of the high level of privacy, and Sphere, which we'll look at in a minute, is a multifunctional app that acts as a wallet for Zen. If you're curious about how the sidechains work with Horizen, feel free to read their white paper. I'm not going to go into any more details than that today. So, Sphere is a multifunctional app created by Horizen. It's a desktop-based tool that goes to allow us to create a Zen wallet and send and receive money from it. So, first up, go ahead, head over to mlhlocal.host/sphere. I'm going to go ahead and put that in the chat for y'all real quick. mlhlocal.host/sphere, and you can download the app for Mac, Linux, or Windows. And you're gonna need that because I'm going to send you some Sphere in just a moment's time. So can a DApp run without internet access? The short answer is kind of, right? So a blockchain does not have to be on the internet. It just needs to be on a network, right? So can a DApp run without a network? No. Can a DApp run without the internet access? If the blockchain it's on is not on the internet, but on a local network or a isolated network or something like that, then the answer is yes. Bit of a cop-out answer there, but I think that hopefully makes sense to you. When you say transactions are private, does the bank know because the cryptocurrency you have is technically an asset? I'm gonna answer this in a hypothetical sense because I'm gonna go as far as to say the regulations are one of the big reasons why the argument that crypto is private is because it's not regulated in a reasonable way, and whether or not a government could regulate it is its own separate discussion that I don't want to address today. But the TLDR of it, right, is it's an asset. Kind of, but it's not an asset. I don't think it's treated as an asset the same way. I don't want to go into like what it means from a tax implication perspective and stuff like that if you're investing within cryptocurrency. I'm not going to advise you to do that one way or the other or trying to provide you any reasonable insights there. But yes, an asset is something you have that holds value, right? And if you can prove that cryptocurrency holds value, then that sort of works. Not sure what's going on there. That's fine. Do governments invest in crypto? Do they have their own private blockchain that gives them value? I don't know. It would depend. it would largely depend on what's going on. A lot of these private, like, startup crypto companies, I think, peg the value of their crypto initially. Am I installing Sphere in the live stream? I'm not, but I will show you some screenshots that will make it look like, because I've already got Sphere installed. But once the file is downloaded, make sure to open it or drag it to your application folder. And then you're going to have to create a wallet. We'll go into that in just a moment's time a bit more. So there are two main elements of a blockchain. Nodes, a network of computers that form the blockchain. People were asking me about it before. What takes you to GitHub? Sphere. Let me check real quick. mlhlocal.host/sphere. I'm not sure what takes you to GitHub, but if you want a direct link to Sphere, there you go. Okay, right. If you do a download, yes, it does take you to GitHub. Just make sure to download the version for your computer, right? If you're downloading it should be taking you to this page. You're just gonna want to download the current version for your platform. Most of you will be presumably DMGs or .exe. All right. Just to make your lives a bit easier, I'm gonna go ahead and screen share that for y'all, real quick. So I go ahead and stop that screen share, and then I want to share GitHub. Application window, Edge tab, releases. There we go. So if you click that link, it will take you to this page, and then you can download for Mac, Linux, or Windows, right? And it's gonna take you to this page. If you're on Windows, you want to download the .exe. If you're on Mac, you want the .dmg, and if you're on Linux, you want the .deb. I don't know what this one's for. If you're on a platform which is .app image files, you'll know about it. I am afraid I don't. So let's get back. Oh, I've not screenshot that correctly. Sorry, one sec. If you're on here, you want the app, you want the deb, DMG, or exe, or app image depending on your platform, and it should cover it. App image is a Linux file. There we go. Simply put. Perfect. So let's go back to our slides. So there are two main elements of a blockchain: the nodes, the network of computers that form the blockchain, and the miners, nodes that are creating new blocks. Miners have to solve a cryptographic puzzle to create a valid block. Miners get some newly issued cryptocurrency for creating a block. And every cryptocurrency out there started as some block reward for some miner. Where's the DMG? It is on this GitHub page that you get to by going to mlhlocal.host/sphere, clicking download for Mac, and then the DMG is that one right there. All right. So miners, what we said, have to solve these complicated puzzles to create valid blocks, and then get issued a reward or cryptocurrency for creating a new block. Every currency out there, every bit of crypto started as a reward for some miner. So how is information shared on a blockchain? Whenever a node receives new information, it will share that information with a few known peers. That node then shares the information with a few of its known peers. This continues until all information is passed on to all of the connected nodes. This is known as a gossip protocol. Every message is signed by its sender, thereby allowing nodes sending fake information to be easily identified, and the distribution of the information to unwanted targets to be prevented. So, blockchain operates on the concept of asymmetric or public key cryptography. If you've heard of secure shell or SSH keys, that's the same concept. So in asymmetric key cryptography, the data is encrypted, which with one key and decrypted with the other key. These keys always come in pairs. Public key is the user's public identity, the one you pass around to encrypt data, and then you also have your private key, which you can use to decrypt your data. So identity on the blockchain. Only the user can see the original information once it's encrypted, because only the only they have access to their private key. The user's identity on the blockchain is their public and private key. For the user to prove that they sent a message, they can digitally sign it using their private key. Signature, that's what signatures are. Anyone who has access to the public key can verify the signature and confirm they did in fact send it. So a digital signature is another mathematical function. It's a scheme for verifying the authenticity of digital messages. So let's talk a bit more about the Horizen platform, which is the blockchain network that we're going to be using today. So today, most blockchains can only process a handful of transactions per second, while payment networks like Visa support several thousand transactions per second. I argue it's more in the millions, but you get the idea, right? Blockchain is typically speaking slower and doesn't scale as well. If you've ever tried to make a transaction on the Bitcoin network, you'll know they can take well over half an hour sometimes. In the case of Horizen, it's usually about 10 minutes, depending on how lucky you get in that respect. So Horizen presented sidechains as a solution. A sidechain is a full blockchain in itself, with the main added feature of being interoperable with the main blockchain. That's not normally possible with the way blockchains like Ethereum or Bitcoin are designed. You just can tweak the features of a single chain to satisfy their needs without affecting the other chains. For example, sidechain A can be for a treasury, and sidechain B can be for supporting the smart contracts for music sales. These can interact with each other and the main blockchain when requested. So how can you use sidechains? Since each sidechain is a full blockchain, it requires the implementation of blockchain code. Horizen provides a sidechain SDK with all the necessary components required for building blockchain in a single toolbox, and all you need to care about is the application-specific code. So now you can get started on your application faster than ever. So what are you going to learn today? We're going to create a web application interface, which is going to be this Pong game. So basically it connects to Horizen wallet and places a bet. If we win, we get a payout from the Horizen wallet. If not, it keeps the coins. So we're going to deploy a Pong application. But we said we're going to bet Zen. So we're going to go through 3 steps to create this. First, we're going to launch the Pong application. We're going to set up a Zen wallet, and we're going to interact with the Horizen blockchain. So let's create a Sphere wallet account. So once you've installed the Sphere wallet, you're going to end up on a page that looks something like this. Once the application is installed, open it up. You will see the following page. Click on Create New Account. That's the smaller bit at the bottom. Choose an account name and strong password, then click Proceed to creating an account. To context, this is a local password and username. It does not get stored outside of the Zen account. So once you've done that, you'll be able to create a wallet. You'll see a screen on the left of the application, and click on Add Wallet, then click on Create a New Wallet. Name the wallet Test Wallet, My Wallet, MLH Wallet. It doesn't really matter. And then click the checkbox that says Require Password and set a strong password. You don't actually have to do this, but it is recommended. And this password will be required when trying to send Zen from this wallet. Again, this is a local bit of security. So generate the backup phrase, and then copy it somewhere safe and enter it in order again. Acknowledge the warnings to complete the wallet creation. So once you've done that, you're going to have to click. Basically, you have to click all of the names, all the words on the screen as you acknowledge your backup phrase. And then once you've created your wallet, you're going to be able to get your Zen address, and then I'm going to need your Zen address. I'm going to give you a link in just a moment to a Google form to send me your Zen address so I can send you some Zen. So quick reminder, if you haven't already, make sure to download Sphere at this link, and then you want to follow these quick instructions. You want to open it, create an account, set your username and password, create a new wallet, walk through the steps with requiring a password, save your backup phrase, verify you know it, and then you're going to have an address. Give me 2 seconds to get y'all a link to a Google form to get Zen, and then save, send, copy that link. that work in a private tab? It does. Fantastic. So we want to do... All right. So if y'all head over to hackpack/getzen, that is the link. I'll put that on screen as well. Right, head over to hackpac/getzen and fill out that form with your address. This is going to take us several minutes for me to do. I currently have half a Zen in my wallet. I have to split that out so I can send it to everyone. All right. I believe I've got 50, so I want to do 0.01. Think that should work. Confirm. All right. How do we send our info? You need to send that link on screen. It's gonna take me a minute to send y'all your Zen because I have to wait for the transaction to basically splitting up the contents of my wallet to verify, and then I can do it, which is always fun. So what am I looking for? Capital as well. How do we know where our info is? If you could follow up on what you mean by that, that'd be great. So I'm gonna continue, and then once I can start sending everyone Zen, I will start sending off I'll start sending out value. But at present, I'm unable to do that. Yeah, it's taking its sweet time. Nope, don't bother sending address on chat. If you want to send me your Zen, post it, send it to hackpack/getzen. Let me update the ticker to do that. All right, there you go. So the backup phrase confirmation takes a lot of time. Yep, it's a little bit tedious, I will admit. So I'm gonna go ahead and continue, and then I'll start sending off that Zen once the transaction I'm waiting for has confirmed. All right. Yep, you have to create a password for the wallet. So let's recap. So we have created a Sphere wallet and populated it with some Zen. Next, we need to get source code. Should be fine. All right. So, to go ahead and proceed, are crypto wallets linked to the blockchain as well? That's a great question. Yep, yes, they are. So we want to head to mlh-local.host/Horizen ping pong starter, which looks like that. And it'll take you to a GitHub page where you'll have access to a run on Replit button. That's this link there. And once you've done that, you'll see this UI, which is the Replit browser. I promise I will send everyone who has sent me their addresses. I've currently got 20 responses in the queue. The second I can, I'm currently waiting for a transaction to post so that I have the ability to send them off, because we have to wait. Every transaction has to wait for the network to approve it, which can take about 10 minutes at the worst of times. So as a quick reminder, head over to mlh-local.host/Horizen-ping-pong-starter. Click on the Run on Replit button, log on a create account, and then view the code on Replit. It will look a little bit something like this. It could take a few moments for it to deploy. So Replit has three main windows. The leftmost one displays the folder structure or file structure of the application. The middle one shows the code, and the right one is a terminal that we can interact with and see logs and the such. So transactions on the blockchain. In blockchain, transactions are messages to the entire network, informing it of a transfer of money. These transactions are written into the blockchain and therefore public and unchangeable. Cryptographic wallets help in creating transactions. So the term cryptographic wallet, which is the term is an application that has three main functions, like Sphere, managing your keys, showing your balance, and creating transactions. Lovelace, where we get your wallet address. So once you're in Sphere, you can see your address will be up here. You have to hover over that eye, and you can copy the address to the right of it. So once we're on, all right, so we're going to go so once you're on Replit, we'll get to that in just a moment. So we have to create a .env or environment variable file. So add a new file at the top by clicking the add file button in REPL. Name it .env. That's going to be a full stop followed by an env. That's a hidden file that stores secrets. And then open up the file and then type in all caps zen _pong _wallet _seed equals, and then paste in quotes the 24-word backup phrase that you copied from Sphere inside earlier, right? That's the one you have to re-enter to confirm you should have stored safely. So once you've done that, there's a bubbles flying out my window. I don't know why. Probably some kid with bubbles. But yep. Once you've done that, that's pretty much it as far as the .env configuration is concerned. And now we're going to talk about smart contracts. I'm still waiting. If you all want to monitor this transaction, once this transaction is shown as confirmed, then I can send you all your Zen. If you want to get access to the REPL, it's mlh/local.host/Horizen ping pong starter. Can you send the code shown in the last slide? Sure. It is zen _ pong _ wallet _ seed equals, and then your seed. That's what it is. Help with the I'm gonna make your lives a whole lot easier real quick. I was going to. I don't have a link to it. Once you've checked in, you should have received an email with a link to the slides, to which you can follow through as well if you do fall a bit behind. All right. So smart contracts. A smart contract is basically software on a blockchain. It allows the performance of credible transactions without third parties. It is a collection of if-then statements that will execute based on predefined configurations. So smart contracts can be used anywhere there is a requirement for a middleman. For example, music artists wanting to sell their music usually need to go through a distribution network. That could be iTunes, that could be Beatport. I'm really struggling to think of anything else other than iTunes that sells music anymore. But, they exist. So, for example, instead, they could set up a smart contract that releases a copy of their music to anyone who's fulfilled the clause of the smart contract, i.e., transferred the appropriate amount of cryptocurrency to their wallet. Because you can see transactions publicly on the network, you can see when that's been done. So smart contracts provide a lot of advantages. They're very safe. Smart contracts run on a blockchain where trust and transparency is implicitly built into the system. Sleepy Eyes, if you forgot your backup phrase, just create a new wallet and then go from there. They avoid the need for a large chain of middlemen. I don't need this massive. You don't need iTunes and then Columbia Records and then anything else in the way, right? It's less prone to manual errors and guarantees outcomes. Since smart contracts are irreversible, and tamper-proof, once the self-executing smart contracts are in motion, the outcome is guaranteed. So, let's take a look at some code in the replet. So once open up that index.js file, which is inside the public/scripts folder, and then scroll way down to lines 186 to 188. And it shows 3 main methods on the UI object that we are calling when the game is started. That's going to be UI.startGameForm, start the payment form, and start the prize form. Let's take a look at what these functions do one by one. So start game form, when the user clicks the start game button, the event listener kicks in, line 87 of the same file. In line 90, we create a game by calling the API, then store its details in the game wallet and the state.game objects. As you can see right there. State is just a global state object we're using to store global information. This is going to be in the replet, so once you run it, you should be able to access it that way. So if we scroll further down to line 94, we can see we update the payment instructions with the game's wallet. And then line 95 to 98, we hide every other screen but the payment container itself. So if we continue this file and we go down to watch for payment, it's the most important part of the start payment form function. It waits for the notification of a payment to the game wallet. Once it receives this notification, it starts a new game. If it does not receive a payment, it checks again in 5 seconds. That's line 144. It will keep waiting for the repayment unless we explicitly quit the program. Where it's in the wallet, you can see on screen, it's hackpack/getzen. It's scrolling the ticker along the bottom. So once the game is finished, this function checks whether the user has won or not and displays the corresponding message, which you can see happening here. UI display display win and display loss, and we can also display results. Once the game is completed and the user has won, the start prize form function gets triggered, which takes in the user's wallet information, sends Zen coins to it, and returns the transaction details. So if we take a look at the index.js file in the root of the application, so not public/scripts that's index.js, but just like index.js in the root of the source, is where most logic of the code sits. To register a game, we first get addresses of the game, then register it using the register game method in game.js. So how do we know if the user has actually sent money to the game's wallet? Well, the /API games ID payments route takes care of it. Let's look closely at lines 103 to 113, which is where the magic happens. Believe my Zen wallet has just done its thing, which means I should be able to send Zen to people, right? Yes, I can start sending Zen to people. Oh, brilliant. Okay, so we're going to I'll be back in just a moment. Actually, I'll stay on screen, but I'm going to be sending Zen to people. Actually, can I screen share this? I think I probably can. If I share screen, I share an application window, Sphere by Horizen. There's nothing sensitive in here, he says. All right, that's the Sphere application. We can see what I've done. So ignore these numbers. They don't make anything reasonable. So if I go to my thing, there's 40 responses. Hopefully I have 40 wallets I can distribute to. If I don't, we'll go from there. So I'm taking an address, I'm sending to it. I'm setting the max of this particular address. So it'll be 009 Zen, which is a bit sad, but oh well. Can I set this to 0? Nope, that's fine. And then I can click confirm. And that will go. This is going to take a while. Lovely. All right, so if I go here. All right, if I go here and I click send, I send to that. And then I tick max, and then I click. Oh, the UI is just not doing it today, is it? Okay, send max. Standard. I think it's upset because of the it's upset because of the line break. Okay. Y'all get to see me distribute massive amounts of Zen. When do we get the JS file again? When I'm done with this and y'all have your Zen, then we'll go back to the JS file. This should only take a couple minutes. Fingers crossed. I do have 43 of these to do, so we'll see what happens. But, alright. Alright, send the max to there. Send the max to there. Believe there's a race condition on the UI there, which is a bit frustrating. Yep, you'll see transactions immediately. They'll be pending for a minute, but you should see them pretty quickly. Alright, send max confirm. We are probably going to have to lower the value of the game in the game in the code, but that's totally fine. Alright, max confirm. Okay, send to max confirm. Alright, max confirm. Is the Zen blockchain a fork of some other, or is it from scratch? I believe it's from scratch. You can take a look at the white paper, which should be linked in the slides somewhere for y'all. I don't know what you missed, but you should have, if you checked in, you should have a link to the slides you can follow along to as well. How do you get the address? It will be, so if we go to a wallet, right, and we go to that info, we can see the address there. I just want to confirm. Who did I send that to? To Zed. Okay, perfect. Let's just go on. So on 10. All right, send to max confirm. All right. All right. Send max confirm. All right. Somewhat curious if this number isn't going down. Don't know when it will go down, but it will go down eventually. It should basically, I should basically be zeroing out my wallet here. That's just fun. Confirm. Really fun project. If you want to build an awesome project this week, figure out a way to automate this with the Google form. That would be an awesome local hack day project. Can we run some script to do this? Yes, theoretically you could, but I don't have one, so that's where we're at in life. All right. Yeah, I want the next one. No, this is totally automatable. I just don't. We just haven't written a tool for it. On screen, hackpack/getzen will give you will allow me to send you Zen. We'll get back to the Pong game in just a moment. We're just doing this now. Yes, I am basically being a bank right now. It's good fun. Get hyphen Zen, not with without the hyphen. All right, max confirm. For context, I don't normally do this workshop with this many people. I think we peaked at over 200 people, 200 of you watching, which does prove to make this more complicated. And confirm. Do. Alright. Alright. Send. Max. Confirm. No wallet address in that one. Almost there, he says. As I've got, I'm like less than halfway still, which is fun. I do know I'm gonna get stuck where I don't have enough addresses, so I am probably gonna have to. Basically, if you were in the second half of people, it's gonna be a bit more delayed for y'all. But it says fine. Yep, it's gonna say pending for about 10 minutes. Don't worry about that. The network has to confirm that I've not broken the network's rules, which are, you know, hacked it. It's all good. Yep. No, that's all the Zen I'm able to give you. I only had half a Zen, so, yep. Yes, the delay is because this takes quite a while to do. Alright. Some more stuff going on in chat right now. Yeah, that's exactly right. What I had to do is, because basically the way the network is set up, so I received, you know, half a Zen from MLH that I'm able to send to all of you. But because you have to wait, you can only ever have one pending transaction per address. I had to make a bunch of addresses in my wallet so I could then batch split, and then I could send all these transactions. I have to wait what would probably equate to almost a day to send all of you Zen. So this approach is definitely for the better here. And we can now see addresses of past workshops I've done. Alright, we're finally past the halfway point, which is great. Alright, confirm. And if you see these addresses on screen, you should be able to look them up on Horizen's Explorer, which would be quite cool. Alright, max, confirm. Yep, that's exactly it. Yeah, you can have as much Zen as you want on an address in a wallet. So yeah. Send. Alright, confirm. Would love a script for this though. Alright, max, confirm. Alright, just give me some time. It's 4 rupees, fair enough. I don't know what rupees are in dollars. I do know I'm sending about 5 cents to everyone. But hey ho. Alright, max, confirm. Your wallet, when you're receiving the Zen, should show you the counter value of what I've sent you, to be fair. Alright. Line break. Confirm. Alright, we got 15 left. The Horizen folks gave MLH a bunch of Zen. MLH gave me half a Zen. I don't know the exact numbers of it. We've got. I could probably look up the amount and the address where I received Zen from. Hell, you could probably look up the address that I've got and see where it's. If you were to find one of these addresses, you could absolutely figure out how much Zen MLH has. I don't know what the tap would be, but you could figure it out by looking at the Explorer. Alright. Alright, 39 to 50. Yes, this is actually a mainnet account. I am technically speaking sending all of you 5 US cents in Zen. Alright, send max confirm. Send max confirm. Alright. Alright, send max confirm. Got 6 left, which is exciting. Thanks so much. It's making this a little bit less mundane. Alright. Send max confirm. Yeah, we can now see some of the transactions. The first ones I sent have now been approved by the network because that number is beginning to tick down. And I guess I would need about 50 addresses, which was spot on because I've got like 4 left and I've got a bunch of addresses left, so perfect. Alright, send max confirm. Alright. Send max confirm. Alright. Alright. And here is the last one. Brilliant. Yeah, that's about right. I'm saying 5 cents to everyone. Perfect. All right, that is everyone. If you sent me your address on the Get Zen form, you should have now have received your Zen. That's going to be it for what I'm going to be sending today, I think. That screen share is a bit wonk. So we'll go from there. All right. It's fine. We are, because of time, we are going to have to move on, but that's totally fine. All right. I'm going to log that form now. Which I can do by toggling responses. Perfect. Okay, perfect. All right, if I go back to my banner and I remove the Get Zen form because I've now disabled it because of time, that's going to be it for Get Zen today. But that's going to do. So if we head back to REPL and we open up the index.js file in the root of the project and scroll down to line 103, we will see the following on screen. We have to ask ourselves, how do we know if the user has actually sent money to the game's wallet? And no, the application's not just going to open up the Sphere wallet like I just did and check up on it like that. We're going to have the /API/games ID payment endpoint, which does this for us. And if we look at these lines, we can see all the magic happening. So first, we get all the transactions for the wallets of the player wallet, and filter out those transactions that are not from the game's address and that occurred before the start of the game. That's on lines 106 and 107. If there's any transaction left, we send the details of a transaction to the UI, or we return an empty list, which means it's not happened already. So, to update the player's wallet after they have won, we first store the player's wallet info in the game object, that we create and broadcast a transaction and store its details in the game object too, which is what's going on further here on lines 62 to 72. So if you want to go ahead and play the game, you want to launch the web app by clicking the run button in the top, which will take you to something like this, and you'll be able to see the game, and you'll be able to start new game. Once you click on start, it also transfers 0.05. How much did I send everyone? I sent 001. You're gonna have to lower that. You have to add a 0 to that number. Let me figure out the best way to do that. Give me a moment. // What was the link from before? Oh dear. Okay. Let's go back to the REPL, which was further up. Alright. If we go to MLH localhost / Horizen ping pong starter. Okay. Yeah, I think I made a rounding error on my end and thought I only was able to send you all 0.01, not 0.0. Sorry, 001, so 0.01, which is kind of my bad. But if we share my screen, we can then see, we can now see the code, which is great. And if I open that up on Replit, log in with GitHub. Alright. I think I'm already in dark mode. Perfect. So we're now on the ping pong game Horizen. It's cloning it. It looks something like this. Alright. So if we go to index.js, I don't think it checks for... There's not a check for a value. I have a HUD doesn't check for a value anywhere. It don't... Yeah, it actually doesn't on the library. Game... Alright. Various private keys, unspent transactions. Just confirming this real quick. Because it wants, we've established it wanted 0.01, right? 0.05, okay. Alright, so we're just gonna control F for that. It's not, I don't believe it's gonna be in any of the code or any of the code on the back end. It's not. So I believe that means that if we go to public scripts game.js or API.js, index.js, there it is. We can make this 0.005 Zen. I don't believe that's gonna make a difference. So yeah, that's fairly straightforward. If you go into that index.js file and you search for the 05 and you create 005, I am pretty confident it's not actually going to care. So you are welcome to send pretty much any value to it. Yeah. Yes, I did. I do apologize. So let's go on from there. If you're having further issues, then let me know and I will poke a bit more. But I am pretty confident it's fine with any actual value. I don't believe it's looking for a set amount. So then we want to fill in the address, the amount in the screen on Sphere. You've just seen me. You're gonna have to send more than 000, but it could be 0005, right? Doesn't actually matter. Any amount that's less than what you've got should work. But fill in the address and amount in the screen and click on confirm. You will then have to enter your wallet password to confirm. Send a relatively small amount and you should be good to go. and then click on the click for payment. You'll be redirected to the game's screen. So, for single player, press 1 in your keyboard. Q and A moves your paddle up, Q and up and down. And if you lose, you can try again. If you won, you'll need to input your wallet address to collect your winnings. Enter the address of your Sphere wallet and click on redeem your prize. But you're not going to get any money because the code is broken. So we have to figure out what the issue is. So to start the game, yeah, sure. Give me... Alright. I will show what needs to happen real quick. Just need to check. Do I have a wallet that I can point to? View your backup phrase. Alright. I have a backup phrase. This is a wallet that has no value in it, so I have absolutely no problem showing this to y'all. So if we create that .env file from before... okay. I don't want it there. I want it in the root of the app. Okay. .env. And then if we go like way back, it's zen underscore pong underscore wallet seed. There's a seed. Oh dear. All right. There's definitely a better way of doing this, but I'm not bothered enough. I'm pretty sure this is technically VS Code underneath, but... Alright. Save. Y'all now have access to wallet. If I click run... we can confirm this right now. I can send an arbitrarily small amount to it and see what happens. Start a new game. It wants a tiny amount to this address. If I go ahead and send to that address, we'll do 0.005 to it. Well, actually, we'll make it even less. We'll add an extra 0 to that. See what happens. Confirm. And then we'll get the address of the wallet I sent it. And click check for payment. And it works. It doesn't actually care about the value. Nope, Adam, I cannot show you the ENV again. Because that wallet theoretically now has some currency in it. But if we use A and Q to move up, it works. See if I win. Hooray, I won. If I provide my wallet address back to it, redeem your prize, nothing's ever going to happen. There we go. So, we've established that is just a front-end display. All good. Let's go back to our lovely slides. For Adam, here's your .env file. It looks like this. The address for context, the address I put in is not the address of the MatMLH wallet with the load of Zen in it. So it's all chill. All right, if we go back to... Uh-oh, you didn't get any money in your wallet even though you were promised some. Where do we think the issue is? So, open up the index.js file inside /lib/zen. Do you see the unfinished create transaction function? That's definitely there. So we're gonna have to fill it in, fill it up to get money in your wallet. So that's the lib/index.js function line 67 or so. Sorry. Yeah, lib/zen index.js line 67. I'm not going insane. I probably am. That's all good. So let us learn a little bit more about transactions in the blockchain. When a transaction sent on a blockchain, it is locked and can only be unlocked by the private key of the receiver. Imagine you've received 10 Zen from your grandmother as a Christmas gift. You now wish to spend 2 Zen to buy a nice pair of Sony headphones. Now we're going to do Audio-Technica headphones, right? Okay. My Sonys are somewhere else. Okay. So let's walk through what would happen. Yes, for $5 we're gonna buy a pair of ATH M50s. Yes. You each create a transaction in which you send the appropriate amount of money to store to buy your pair of headphones. A transaction comprises of inputs and outputs. Inputs are the amount spent by the sender. Outputs are split into the following parts: the output that you would want to send the payee, the change that gets added back to your wallet. 2 parts. Looks something like this. I have 10 Zen. The store gets 2 and gets 8. So the input transaction is 10 your grandmother gave you. The 10 Zen gets split into 2 outputs, 2 for the store and then 8 for change. Remember, when we mentioned... Nah, I like my Sonys more than my Audio-Technicas. Remember when we mentioned... These are ancient. They're like old M50Xs from like when I was in secondary school. But to spend the 10 Zen received with your public key, you have to unlock it using your private key. The private key is used to create a digital signature, which, if valid, unlocks your money. Once the signed transaction is ready, we broadcast it to the blockchain. Did you click on receive to receive the value? The redeem your prize bit, that's currently broken and we're fixing it. That's why it didn't work. So the private key is used to create digital signature, which, if valid, unlocks your money. I.e., the network will only be happy if you sign your transaction saying, yep, I want to spend my money. Right? No one else can do it. Once the transaction is ready, we broadcast it to the blockchain. Nodes and miners verify the sign is valid before including this transaction in the next block that is created. The outputs of the transaction are again locked. Locked transactions are also called unspent transaction outputs, or UTXOs. The 10 Zen that was the input to this transaction is recognized as spent. When you own X Zen, that means you received X Zen as a transaction output, and you haven't spent that output yet. So, for the steps before a transaction are 2 or 7, depending on how you look at this. First, get all of the required information. We need the private key of the sender, the person I need to sign the transaction. I need the private key for that. I need the unspent transaction outputs, the UTXOs. That's because I need to prove that, hey, I do have this money. I need the address of the recipient. Once I have those 3 bits of data, I can then create the transaction, use my private key to sign it, serialize it, that means convert it into the form the blockchain expects, and then broadcast that transaction to the world, telling everyone on the Horizen network, I am sending 1 Zen to Adam because I want to. So, if we start writing this create transaction function again in lib/zen/index.js, line 57, we need to we create transaction method takes 2 inputs: the game address, which is the address of the game's wallet, and the address that we want to send money to. No, Adam, I don't have 1 Zen, I'm afraid. I know you would love $50 right now, but I don't have $50 to give you. First, we get the private key associated with the game wallet, since we need this to sign the transaction. And then on line 6, a get wallet address function gets a set of addresses that belong to the game's wallet. And on line 60, we find the address that maps the current game wallet. And line 61 gets our private key of the wallet and into a variable called private key. That syntax is called object destructuring in JavaScript. I've not been showing JavaScript enough during this workshop. I'm off brand. All right. So, we then have to set the block height to 450,150. We need the BIP 115 block height, which is going to be the block height minus 150, and we need the block hash. The next set of lines are all constants that we will use while creating our transaction. Block height is the block at which you want to commit the transaction. You can look to mlh local.host/insight to find the latest block on Horizen. So let's go ahead and do that. We're going to go to mlh local.host/zen. insight, which will take us to this page. And we can see these blocks. We just want to take one of these last ones. So 906,575 is a totally valid one for y'all to use. That's Zen Insight. And then we just found this block over there. So let's go back to a quick detour. What is replay prevention? If you know the answer, go ahead and throw it in chat. But for all those that don't, let me explain it for you. A change in the code rules of blockchain leads to something called a fork. If someone users reject that change, it causes a hard fork. After a hard fork, if a transaction in one fork is replicated in another fork, it is called a replay attack. To prevent replay attacks, we need to pin our transaction to a block that is only on one of the forks and will not be orphaned. If the block used for the replay protection gets orphaned, the transaction will be unspendable for at least 52,596 blocks. Why that number, do you ask? This is to avoid creating an infinite storage requirement from a full nodes, which would be necessary to maintain all the block headers indefinitely. 52,596 block headers requires a fixed size of approximately 4 megabytes. We assume that it takes 1 year for a chain to grow that many blocks, and this is how long we want to confirm no double spend happens. Double spending, it was a thing a while ago about like Bitcoin being forked. Everyone who had Bitcoin before in the common history now had basically doubled their value, but not really. So let's go back to the code. So to find the hash of a particular block, go to that Zen Insight link. We'll need type the block number whose hash you need and press enter. In the page that pops up, you can see the block hash for the block just below its number. So I'm gonna go ahead and show that again. So if we go here, if we enter the block and we search, we can see the block hash right there on the screen. And we're going to want to paste that back into our code. Yep, it does take us quite long. How long does a single block take? It depends, right? The miners have to mine, to do it. If all the miners have stopped for some reason, it can take a very, very long time for a block to be populated. And yeah, they do tend to be quite a lot. There's a lot of material to go over, and we have 15 minutes to go through the rest of it because the leaderboard update is going to be at top of the hour. So do apologize if I'm going a little bit faster than some of you would like right now. So we have to complete the create transaction function. This function gets the transaction's details, creates the transaction, signs it, and serializes it. That's that second part of the two steps required to create a transaction, right? So first, we need to get the transaction details. We need to set a constant called UTXO, which is going to get UTXO for the wallet address. And it's basically going to give us all of our unspent transaction outputs. That await on line 70, that's because it's an asynchronous function, and we need to wait for its result to come back. Then on line 71, we need to create our transaction details, which is going to equal an array with an object with one element in it, which is going to be the address we're sending to, the satoshis, and that's which are basically our unspent transaction outputs. We're going to get those from the UTXO constant. So we have this function called UTXO. It gets data for us. Let's call that. And when we create the object, we need to provide all these details to it. So then we need to create the raw transaction by using the create raw transaction method from the Zen Cache.js library. It creates the following outputs: UTXO transaction details, the BIP 115 block height, and the BIP 115 block hash that we got before. Then we need to sign the transaction. So again, we're going to use the sign transaction method from the Zen Cache.js library, which is going to take 4 properties: the raw transaction, the index of the transaction in the raw transactions list, which is going to be 0 in this case, the private key of the game wallet's address, and whether we should compress the public key or not. Then we have to serialize and broadcast a transaction. To serialize a transaction, again, we use the serialize transaction function from the Zencash.js library, and then broadcast it using the broadcast transaction method that's already written in the Insight API JS file. Now I can breathe, because that's all of the steps to fix that. Once you've written all this code, we should be able to get the money out of our wallet now, into our wallet now, and we can play the game again and verify it. I'm assuming this is reference to the transaction I sent earlier. Yep, there are no longer any pending transactions on any of my addresses, so yes, they were all confirmed. So you can go ahead and run your game again, and it should work. Again, like we said, you don't actually send 005 Zen to it. And then when you send it, it'll say your prize has been sent, and it'll give you a link to the Explorer to see that transaction once again. So because of time, I'm going to hope that you got through that. You should have a link to the slide which will walk you through those steps if you are behind at all. Did you change the block height? Nope, we don't really have to change it. It's not the most important thing in the world. There are ways of automating that bit, but for context, right, we only have to really do it here. Because there's a block blocks get created rather quickly. So let's recap. We launched the app and learned how to create and send transactions to the blockchain and receive our prize money. The Horizen Early Adopter Program is an opportunity for developers to gain early access to Horizen's newest releases and product features before they are publicly available. HEAP members will also receive Insight-only webinars, pre-release product demos, and tutorials and other free learning materials. You can check out the HEAP program at mlhlocal.host/HEAP. There's also the Horizen Developer Environment, the HDE. You can contribute to open source project as easy with the Horizen HDE. HDE is a social platform educational resource for all levels of developers. Provides developers with the opportunity to work on cutting-edge technologies alongside the Horizen engineering team and developers from all around the world. Let's recap and then go over some next steps. So what did we learn? We learned an introduction to blockchain technology and Horizen, how to create a Sphere wallet and account and use Zen coins. We watched me send loads of them to all of you right here on stream. And we learned how to create and send transactions to the Horizen blockchain using the Sphere JS library. So a couple practice problems for later. You can make this a 2-player game. If you wanted to create a side chain specifically designed to support our Pong application, that would change compared to the Horizen main chain we used today. You're welcome to do so. Oh my gosh, it's Electric Hamstar. I wonder who that is. But let's go ahead and check out the quiz. So we can go ahead and fill out the quiz at mlhlocal.host/quiz. I'm going to go ahead and do that with all of you here on stream right now. So if I go ahead and head over to that link, we'll see this right on screen. Which MLH Local event did we attend? We attended blockchain basic. Sorry. Which one? We have to find Horizen. Don't totally remember. Okay, it's right here. Basics of blockchain with Horizen right at the end. Which school organization hosts this event? It was Major League Hacking. And what is the email just used to sign up for this workshop? One moment while I enter my email address for all of you not to see, because I don't like spam, and I love all of you, but it doesn't mean I trust all of you not to spam me. So you then see this screen, thanks for attending the basics of blockchain with Horizen quiz, and then we can go ahead and start filling it. So how did you find the content of the workshop? I think it was extremely useful and that I did an amazing job, but I don't see the results, so if you think otherwise, you're absolutely welcome to tell me otherwise. Hi, Swift. I love you. Don't fire me. No, just joking. Before the workshop, how familiar were you with the blockchain technology? Personally, I've done this a bunch of times, so I was fairly familiar. And how interested am I in building a simple blockchain application? Honestly, I think it'd be super cool, but I also don't have the time, so I'm somewhere in the middle. And am I interested in the HDE program? Me personally, I'm probably on the fence, and the same with HEAP. Do I have any feedback or comments? Yep, Aaron is the best coach. Sorry, Jack. That feels like the appropriate one. I'm going to chuck a melon and a shark on the end of that for all of you to enjoy. But what is the name of Horizen's cryptocurrency? If people know this in chat, they're welcome to throw that out at me. But I think we've seen it 1,000 times, and it is Zen. What are two main elements of the blockchain? Is it the nodes and the miners, the notes and the ledgers, and the blocks and the chains? That's a really hard one. I think it's the block. No, it's the nodes and the miners, which are great. Notes and ledgers, that's more like real-world accounting, and blocks and chains, that's the real gotcha one here. And information is transferred over the blockchain with what? Is it the side chains, the communication protocols, or the gossip protocol? I think I mentioned this towards the beginning, and someone's already put out in chat, it's in fact the gossip protocol. Make sure you're doing this quiz so you can get points for your guilds for local hack day share, which is super awesome. Do you want emails from Horizen team? I don't personally want more emails, so I'm going to say no. And they'll show me my quiz score at the very end of the survey. I believe I can skip these, or it's going to get mad at me. Nope, I'm going to have to recommend them. So how do I recommend Major League Hacking to a friend or colleague? Well, obviously a 10 out of 10 for both of these. That's just me personally. What was the most helpful or interesting part? Aaron's awesome attitude. Think that's probably how we do it. And then I'm just going to go ahead and submit this. I'm going to say nope to this one. And we should see my results. Nope. I don't know why. I think my ad blocker might have told me no. So hopefully that's the case. Otherwise, we'll take a look at that after the stream. That being said, I don't see any burning questions in chat anymore. Make sure you to fill in the quiz at mlhlocalhost.com/quiz so you can get your prizes. And if you haven't already, make sure you check in. The link should be ending in the next couple of minutes at hackpack/LHD share Horizen, so you get awesome points for your guild. That being said, thanks so much for coming to Basics of Blockchain with Horizen, and you should be psyched for the leaderboard update in just a few minutes time. Otherwise, that is it for me. Have a great time at local hack day share this weekend, and I'll catch you later. Bye bye.